Members of a random sample of N shoppers at the El Cheapo shopping centre were asked by a consumer researcher how much they had spent in the shopping centre that day. Let mu denote the mean and sigma the standard deviation of the amount spent. The standard deviation sigma is known from previous research. A 95% confidence interval for mu based on the sample is this. Determine the sample mean. Well, it's just going to be the middle of that. So it's just 150 add 200 divided by 2, which is fairly obviously 175. Based on this confidence interval, calculate the standard deviation of the sample mean, correct to 2 decimal places. Well, we know it's a 95% confidence interval. Now, as it happens, I can remember it's 1.96 today, but usually after a few days of not having used these, I forget what they are. So it's always a good idea to just go through how to find them. So inverse normal CDF, if you go for a center and put in a 0.95, leaving it as 1 and 0 for the standard normal, and then you get your 1.96. So 1.96 is the 95% Z value. And when you multiply that by the standard deviation, you get the standard error, which here we know is 25 because the width of the interval is 50. And so S is just going to be 25 divided by 1.96. So 25 divided by 1.96. It wants it to, I wonder if I should actually use this Z value. 12.76. Okay. The following week, the researcher again took a random sample of shoppers from the El Cheapo shopping centre, but this time the sample size was doubled. What is the probability the difference between mu and the sample mean from this sample will be less than $10? Now, there's various ways of doing this. So I'm going to do it a different way to what they did it in the solutions. They looked at a standard normal. I'm just going to have sigma nu, and that's going to be for this new sample. Now, we know that sigma over root n was at my last answer, 12.76. So I might use more of that. And that means that sigma is equal to 12.7551, which is 12.76, a few more decimal places there, or root n. Now, the sigma nu that I was talking about, which is for this situation up here, that's going to be equal to the previous, but now we've got a new amount. We've got double the number. And so basically the ends cancel here, and you're just doing that divided by root 2. So my last answer divided by root 2 gives me 9.019, and so on. Now, as I was saying, they went ahead and used the standard normal for this and sort of did a Z-score thing. But I found that I could do this just by saying, just using the thing that we've got. So we've got a normal CDF, and up above the mean was 175. So let's just go within 10 either side of that particular sample and use the 9.019 as our standard deviation there, and 175 was the previous mean, and see what that comes to, and it will give you the same answer as doing all that Z-score stuff. So interactive, distribution, continuous, normal CDF, and the lower is 165, the upper is 185. We know the mean was 175, and this was 9.019, and that is 0.73. You'll see it's the same answer as what they got by doing a slightly different method.